Two wires AB and AC are supporting weight W as shown in the figure. Determine the maximum set value of load W if the axial deformation of the members AB and AC is limited to 4 mm and 6 mm respectively. Neglect self weight of the wires. So deformation of AB and AC is given. So this is the arrangement of the two wires AB, which is making an angle of 40 degree. Then it is made up of steel wire. This is wire AC, which is made up of copper. It is a copper wire. Steel wire is having area of 50 mm square and modulus of elasticity is 200 GPa, whereas area of copper wire is 75 mm square and modulus of elasticity of copper is 80 GPa. This vertical distance is given as 1 meter, so that we can easily find out this length of the wire AC as well as length of wire AB. So let us find out the tensions in this particular wire. So we'll use the simple trigonometry over here. So this is the angle made by the wire with the horizontal of 60 degree, adjacent component, and suppose TAC is the tension in wire AC. So this adjacent component will be cos component, that is TAC cos 60. Opposite component will be sine component, that is TAC sine 60. Similarly, over here also, if tension in wire AB is TAB or force in wire AB is TAB, then this is the adjacent component, which is cos component, TAB cos 40, and this is the opposite component, which is TAB sin 40. So there are two components which are acting in the upward direction, that is TAC sin 60, TAB sin 40, which will be supported, which are supporting this load W. And there are two horizontal components, TAC cos 60 and TAB cos 40. Now, from these particular triangles, that is A, B dash and B, sine 40 will be equal to, so this angle is sine, this angle is 40, so sine 40 will be equal to 1 meter, that is 1000 mm divided by AB. So AB will be equal to 1000 divided by sine 40. So take sine 40 on this side and AB on this side, so that we'll get the length of this wire AB. So this angle was 40 degree, that we know. Similarly, this angle is 60 degree. So sine 60 will be equal to 1 meter, this opposite side, divided by hypotenuse. So 1000 mm divided by AC. So AC will be equal to, transfer AC on this side and sine 60 on this side. So we'll get the length of the wires AB and AC from this. Now using this, we'll solve the example. So summation of Fx is equal to 0, forces towards right positive and forces towards left negative. So we have seen that TAB cos 40, as we have seen in the earlier diagram, it is acting in the negative x direction. So horizontal force minus TAB cos 40 plus TAC cos 60 has to be equal to 0, or TAC cos 60 has to be equal to TAB cos 40. So we can say that transfer this cos 40 on this side, so that we'll get the relation between TAB and TAC. So cos 60 divided by cos 40, that value comes out to be 0.65. So TAB is 0.65 times TAC. Similarly, apply the another condition of equilibrium, that is summation of forces in y direction is equal to 0, upward force is positive, downward force is negative. So we have seen that two forces were there which were acting in the upward direction and W is acting always in the downward direction. So TAB sin 40 plus TAC sin 60, they are acting in the upward direction, W acts in the downward direction, so it is negative. Now TAB is 0.65 times TAC. So transfer this minus W on this side, so it will become positive. Take TAC common from both these terms, so it is 0.65 sin 40 plus sin 60, that will be equal to W. Or we can say that W divided by this total bracketed term will give you the value of TAC. So in terms of W, that value comes out to be 0.78. So 1 upon this value is 0.78 W as it is. But TAB is 0.65 times TAC. So it is 0.65 into 0.78. So that value comes out to be 0.5 W. So now we are having the relation between TAC and W and TAB and W. Now let us see the next steps. Now length deformation of AB is equal to PL upon AE of AB. So force in AB is nothing but tension in AB, length of AB, area of AB and E of AB. So we know all these values. So cross multiply by these terms so that you will get tension in AB into length of AB as it is. Transfer this LAB on this side so that only TAB will remain over here. So first we have cross multiplied over here and then take LAB on this side. Substitute all these values. Now delta L of AB is 4 mm, area of AB is 50, E of AB is 200 into 10 raised to 8, and length of AB just now we have seen that it is 1000 divided by sine 40. This sine 40 will go in the numerator so that you will get the value of TAB. TAB is 0.5 W. So find out these values now. Transfer this 0.5 on this side and sine 40 will go in the numerator so that we have written. So we'll get the value of W as 51.4 into 10 raised to 3 Newton.